All right, hello, grade eights. Let's get started where we left off before the spring break. We had just finished, I think it was the EM spectrum, and we had talked about words like refraction and reflection, um, and we talked about translucent, transparent. So today's class is going to be focused on three different types of mirrors. Okay, so you can take these notes down, and maybe one thing you can do during this time is set up a folder, or a binder or a do-tang, something where you can keep all your work organized. Okay, and so first off, most of you have handed in that initial assignment on the coronavirus, so that's really good. Um, um, some of you sent it as a attachment, a separate attachment. Most of you put it on the assignment section, which is actually the preferred way to do things. Okay, so not a big deal if you didn't do it that way, but try to hand things in through the assignments um, um, section on that on our teams for sc8. Okay, and then when I go on there, I can tell who's handed in. It gives me a nice tally. All right, you can take these notes down. You can print this off if you have a printer, or you can just write these down. Okay, so the first one we'll look at is a plane mirror. Okay, so that would be this one, and what it does is it follows the law of reflection. Okay, so here's this would be your mirror. Okay, so there's your mirror. Plane means flat. Okay, so it's a straight, flat mirror, just like a ruler. Now, what we want to do here is we want to be able to measure angles, and so I had a bunch of labs set up using ray boxes where we would have done this. Now, when we want to measure the angle, we have to have this normal line that's drawn in. Okay, so it's basically a line that's just drawn in that allows you to measure the angle, and your normal should always be perpendicular to your surface that the light's hitting. So in this case, it's a mirror. When I say it's perpendicular to the mirror, what I'm saying is it's at a right angle to the mirror, or a 90-degree angle. Okay, and so here's following the ray diagram, we say light behaves as a ray. The incident ray means the one that's going to hit the mirror, so it comes in that way, and then you have the reflected ray, and so the angle is always measured between the ray itself and the normal. So this would be the angle of incidence, this would be the angle of reflection, and so this is your law of reflection right here. Okay, which is basically saying the angle of incidence is equal to the angle of reflection. So for example, if the angle of incidence was 30 degrees, the angle of reflection would be 30 degrees. Okay. Another characteristic of a plane mirror is that the distance of the object in front of the mirror is the same as the distance behind the mirror to the image. So, for example, if you're standing in front of a mirror, you're the object, okay? And then when you look at the mirror, you see an image of yourself, okay? So that's called the image, okay? So what you see in the mirror is called the image. And what it appears, and you can do this at home, when you look at yourself in the mirror, the distance from you to the mirror is the same distance as your image is behind the mirror. And I know that kind of doesn't make any sense, but that's what we call a virtual distance, or the image itself is virtual. Okay, so again, the distance of the object to the mirror is the same as the distance behind the mirror to the image of that object. As well, the size and the orientation of the object is the same as image. So that the size means, so whatever you're looking at. So again, if it's yourself, the image of yourself is going to be the same size as you are. And when we say orientation, what we're talking about is the image upright, or is it upside down? Okay, another word for upside down is inverted. Okay, so is it upright or is it inverted? So the same orientation means it's going to be upright. Now, besides these curved mirrors, beside this plane mirror, there's also curved mirrors. And so that's what I want to look at next. There's two types of curved mirrors. One is what we call convex, and so that's curved outwards. Okay, so now with the plane mirror, the diagram was showing you a single ray hitting it, so that was the incident ray. These are called multiple rays, and when you use the ray box, you have filters that will allow for this. Multiple rays. This is called parallel light rays. Okay, so parallel means that the gap between these stays the same throughout. So think of a parallel as like train tracks. Okay, so here you've got 4 parallel light rays hitting the convex mirror, and what happens is they go outwards, and the word for that is diverge. Okay, so these type of reflected rays, they diverge. Okay, so diverge means they spread apart. So they spread apart, they're never going to be able to touch each other. Okay, so they're never going to be able to intersect. And so the characteristic of the image from a convex mirror is objects are always going to appear smaller, and the image formed is always going to be upright. And so where would you use a mirror like this? So a mirror like this you would see in, say, a convenience store, right? And so you look for that next time you're in a store. Like you've got a curved mirror that's usually in the corner on the ceiling of the store. And what you notice is if you look at that mirror, you can see all the aisles in the store. So it's basically there to watch for shoplifting, right? And so you can see all the aisles. So what that tells you is because everything is smaller, you can fit a lot of space on that mirror, right? So you can take like a whole store floor and the aisles and fit it onto that mirror because everything's been shrunken down. Second one is curved inwards, and that's called a concave mirror. And so what happens here is the light rays, they meet up at a point, and so the word for that is they converge. Okay, so that means they converge means they come together, and they meet up at what's called the focal point. So that would be the focal point where all the light rays come back and connect. Now, after they hit the focal point, they're free to spread out beyond that. The image formed. Now, with the last one here, the object always appears smaller. The image formed is always upright. Okay, so that's true regardless of where you are relative to the mirror. For the concave mirror, it's more complicated. So here, the image formed depends on how far the object is from the mirror. So the orientation, upright, inverted, the size, bigger or smaller, it all depends on where you are from the mirror. So like, are you far away from the mirror? Are you closer to the mirror? That's going to dictate what type of image is formed. Okay, and I'm going to have you, I want you to look up, there's basically 3 different cases of what type of image you can expect. So I want you to look that up. You can use your technology to find out how the image changes by where you are relative to the mirror. Okay, so I'll stop there. So if you haven't handed in the coronavirus assignment, make sure you do that. So here's the questions I'd like you to do for, have these done for Monday. Okay, and so what I've got is, actually before I show you the questions. So I do have, so remember I talked about how I was going to have office hours. So again, class for Science 8, again, the classes are going to be Monday and Thursday. Okay, and so what I'll do is Tuesday we'll make that office hours which is basically if you text or sorry not text if you send me a message on the Teams app. What this means is I can be in live communication with you during this time, and so I'll make the office hours. Let's start with this and see how it goes, and if I need to add more, I'll add more. But let's say let's go with 8:30 to 9:30. Okay, so that will be my Tuesday office hours, and if I need to add more to that, I will. Now, that doesn't mean that you can't communicate with me beyond this time. You can always send me a message anytime on the Teams app, and I'll respond back to you. But for this, this is just a particular time if you need to kind of get instant feedback from me. Okay, and like I said, we'll see how that goes, and I can always make an adjustment on that. Okay, now the questions I like to do. So this is just out of your textbook. I know some of you might have this at home. Some of you might not. Okay, so these questions here, 1 to 6. Okay, so you can just freeze that and just answer that on a separate sheet of paper, and then as well. You can do, let's see, so these checking concepts. Okay, so there's 1 to 6. Okay, you can do those questions as well. Okay, so and what I'll and submit your answers to these questions. Okay, so those 2 pages there, and then what I'll do is I'll give you a completion mark for handing those, submitting those answers, and then what I'll do is for Monday's class, I'll begin class by going over the answers to the questions. Okay. Okay, so I'll stop there. So again, just continue to be safe, look after yourself. Your health comes first. Okay, so make sure you're looking after yourself, looking after the people around you, and I'll be again looking for any questions that you have and trying to get back to you as soon as possible. All right. Okay. Talk to you later. Bye.